Hello everyone, today I'm going to use this PPT to explain the poster I made in Group 10. First, I want to ask you a question. If 10 pigeons are flying back to 9 pigeon nests, what will happen? The idea behind this question is an important math principle we will talk about today, the pigeonhole principle. If k is a positive integer and k plus 1 objects are placed into k boxes, then at least one box contains 2 or more objects. The pigeonhole principle is also called the draw principle. It was brought up by a German mathematician named Dirichlet. The name comes from the vivid picture of pigeonholes and pigeons. It's easy to remember. Now that we know the principle, let's look at how it's used in real life. 1. Computer things. Hash algorithms are like arranging small rules for data. When there's more data to store than there are small rules, a lot of data will be in one rule. 2. Coding theory. Messages to be coded are like keys in a line. The unique code words are like small labels. When there are more messages than labels, messages will share labels and mistakes can happen. 3. Number theory. If we pick any n plus 1 whole numbers, there will be 2 numbers whose differences can be divided by n. You can write down a few numbers on paper to check this. 4. Graph theory. We study how things are related. With the help of the pigeonhole principle, we can find that in a group of people, there are always some who are either good friends or not friends at all. After learning this, I'm sure you understand better how the pigeonhole principle is used. Next, let's look at 2 problems. The first problem: in traditional Chinese culture, giving rice envelopes during the Spring Festival is a happy thing. There's a school with 200 students, and the number of boys and girls is the same. The school pays 101 students for activity, with 13 boys and the rest girls. They prepared 5 cans of rice envelopes and will give them out randomly. We can use the addition principle to find out how many ways there are to pick 101 students. The answer is C113 plus C171. We can use 2 ways to solve the first question. Method 1, worst-case pigeonhole principle. Think of the 5 cans of rice envelopes as 5 boxes, and the 101 students as 101 pigeons. Here, n equals 5. We can calculate k equals 20. So at least 1 can of rice envelopes amount will be chosen 21 times. Method 2, generalize the pigeonhole principle. Let the 5 can of rice envelope amounts be n, the 101 students be n pigeons. Using the formula, we get k equals 20 and the k plus 1 equals 21. We get the same answer. Now, let's solve the second question. Method 1, worst-case pigeonhole principle. Think of the 5 cans of rice envelopes as 5 boxes. If we want the 28-yuan rice envelope to be chosen 13 times, that means k plus 1 equals 13. So k equals to 29. Using the formula, the number of students we need to choose is kn plus 1 equals 146. Method 2, generalized pigeonhole principle. Let the 5 cans of rice envelope amounts be n, since k plus 1 equals 13. Using the formula, we find that m equals 146. Let's see the second problem. There is a modern school with 33 students. The school offers 4 courses. Each student chooses 1 course, and after that, they get a grade. There are 4 grades. We use pairs to choose the student's grade and the course they choose. There are 2 questions here. First, let's solve the first question. According to the multiplication principle, each student have four grid options and four course options. So the total number of combination is 60. Now let's solve the second question with two methods. Method 1. Worst case pigeonhole principle. Think of the 33 students as kn plus 1 pigeons and the 16 combinations as n boxes. Given kn plus 1 equals 33 and n equals 16, we can calculate k equals 2. So at least 2 students will have the same grid course pair. Method 2. Generalize the pigeonhole principle. Let the 33 students be n pigeons and the 16 combinations be n boxes. Using the formula, we can get k equals 2. We can get the corresponding answers. The pigeonhole principle has wide applications in real life. The pigeonhole principle helps us understand that in certain situations, repetition or conflict is inevitable. Especially when the number of items exceeds the number of categories, this principle is simple and intuitive and has a wide application in various real-world problems. I used some documents. If you are interested in the principle, you can look up these documents after class to learn more. Okay, thank you for watching. Now, I will pass the time to my group member, Peng Shuhua, for her presentation.
Thanks to my teammates Xu Beini for sharing. Hello everyone, my name is Peng Shuhua. The subject I am going to talk about is circular permutations. Now let me share circular permutation in 5 parts. Okay, now I will introduce my first part, introducing the circular permutation. Circular permutation is a special type of problems in permutations or combinations, where our elements are selected from the undistinct elements and arranged in the circles. Only the relative positions of the elements are considered, without distinguishing a start and endpoint. Arrangements that are identical after rotations are regarded as the same permutations. The type of arrangement is known as circular permutations. Okay, so now that we know what a circular permutation is, let's look at the methods of circular permutations. For example, let's consider the persons A, B, C, D sitting around the tables, as illustrated here. Then I rotate it 19 degrees counterclockwise, and I get 4 identical arrangements. But we convert them to linear arrangements. There are 4 different arrangements. Therefore, the number of the circular arrangements of n different objects equal to the number of linear arrangements of n different objects divided by n equal to n factorials divided by n equal to n minus 1 factorials. If we need to consider clockwise and anti-clockwise arrangements, according to the pictures, we find that when a clockwise and anti-clockwise arrangements are not different, when observations can be made from both sides, the number of circular arrangements of n different objects is n minus 1 factorials divided by 2. Okay, we are done with the methods of circular permutations, and we are going to try to use it to do some problems. Example 1, you can pause the videos and read the follows questions first, and think about what is the particulars should we pay attention to in these questions. Okay, right, we need to know that B and C must be adjacent, and D and E are not adjacent. So step 1, we can tease B and C together and arrange them in circular arrangements with 2 identical A's in 3 minus 1 factorials. And notice, because the 2 A's are indistinguishable, we are going to divide by 2. Then B and C can swatch with each other, so multiply by 2. Then 1 times 2 is 2. Okay, now what should we do with the rest of the D and E? Yes, right, we can use the insertions interval methods to solve the problems. As shown in the figures, we can find the remaining 1, 2, 3 intervals. If we want two letters to insert it, that is the permutations of 2 hours 3 equals to 6. Hence, the total number of arrangements satisfy the conditions is 2 times 6 equal to 12 by multiplication principles. Okay, so is it right? Is there any other ways to solve it? Of course, we can solve the problems by writing along. First, we can teach B and C together and arrange them with D, E, and two identical A's in circular arrangement in 5 minus 1 factorials divided by 2 factorials is equal to 12 ways by circular permutations and divisions principles. Then B and C can swap with each other, so multiplies by 2, and 12 times 2 equal to 24. Step 2. We continue to use the Briding methods. Then take D and E together and arrange them with the others in 4 minus 1 factorials divided by 2 factorials is equal to 3 ways. Then both grouped together can be exchanged respectively, so multiplies by 2 times 2, then 3 times 4 equal to 12. Finally, we need to pay a special attention to the fact that D and E are not adjacent, so the total number of arrangements satisfy the conditions is 24 minus 12 equal to 12 by suggestion principles. Okay, let's move on the next questions. Example 2. You can pause the video and read it. After you read the problems, we will find that the adjacents again. So we can use the Briding method to solve the problems. Step 1. Choose the start-moon bodies, fifth bodies, body roof as the single unit. Arrange them with the remaining 15 bits in 16 minus 1 factorial ways. Then arrange the bits that are together, so multiply by 3 factorials. Then 3 factorials times 6 minus 1 factorials is equal to 6 times 15 factorials. Step 2, we find that the bracelet can reverse, so clockwise and counterclockwise are considered identical. So the total number of arrangements is divided by 2. Hence, the total number of arrangements satisfy the conditions is 6 times 15 factorial divided by 2 by multiplication principles. Okay, pretty simple, right? We just use the Briding methods and we are going to the trace interval methods. Step 1, we arrange 15 different bits in the circular arrangement except start-moon bodies, finish body, and body roof, where clockwise and counterclockwise are considered identical. The total number of arrangements is 15 minus 1 factorials divided by 2 is 14 factorial divided by 2. Step 2, start-moon bodies, finish bodies, and body roof must be adjacent. We need one of the 15 permutations to arrange them, since they can switch place with each other. So we need to multiply 3 factorials, which is 15 times 3 factorial is equal to 19. And finally, according to the multiplication principles, we get the total number of arrangements satisfy the condition is 19 times 14 factorial divided by 2. Part 4. Conclusions. According to the above examples, we can determine whether to distinguish between clockwise and counterclockwise is important to selecting collecting formulae. There are our commonly used formulas. According to the requirements of the problems, we can choose the appropriate methods to solve. Finally, this is the reference for me to finish this assignment. Thank you very much for listening. The follow is my email. If you have any questions about today's content, you can email to ask me and I will reply you in time. Thank you. Bye bye.